Methodology in Quantitative Research, Part 1. If you've ever started working on a piece of formal research, be it a dissertation, a thesis, or even as simple as a research project, you probably felt or were feeling a bit overwhelmed by all the technical lingo that gets thrown around. Research methodology, research methods, data collection and analysis, it seems never ending. Well, what is this methodology we speak? Research methodology simply refers to the practical how of any given piece of research. It's the part of the research project that we can look at as analogous to the blueprints of a house. It provides a plan for how we will go about testing our research or clinical question and hypothesis. A research methodology is a systematic approach to solve the research problem and to reach a new conclusion. Importantly, a good methodology section in a research article describes not just what methodological choices were made, but also explains why they were made. In other words, the methodology section should justify the design choices by showing that the chosen methods and techniques are the best fit for the research aims and objectives and will provide valid and reliable results. A good research methodology provides scientifically sound findings, whereas a poor methodology doesn't. Accuracy in research is a research characteristic that provides a way to know how close are the sample parameters to population characteristics. So, accuracy means how precisely the measured value or findings reflect the real or the original values. Feasibility studies are pieces of research done before a main study to answer the question, can this study even be done? They are used to estimate important parameters that are needed to design the main study. Data collected would not be analyzed or included in the publication. A scientific control is an experiment or observation designed to minimize the effects of variables other than the independent variable. This increases the reliability of the results, often through a comparison between control measurements and the other measurements. To assess fidelity, researchers need to determine at the study design stage the methods they will use to assess and monitor the reliability and validity of the intervention. Reporting of fidelity methods in the published product is crucial to allow readers to judge the quality of the study and then replicate it, and to assist the intervention developers in understanding how various factors may have influenced the outcome of their study. For example, if we were going to have an independent variable of 75 milligrams of low pressure, it would really muck the study up if 25 milligrams was given accidentally or unknowingly. How would we know? Well, sometimes we don't. Remember how I mentioned a few weeks back that all research is flawed? Well, here is one potential of mucking things up. A confounding variable is an extra variable that you didn't account for. They can ruin an experiment and give you useless results. A confounding variable can have a hidden effect on your experiment's outcome. For example, in a rural area where we are measuring nutrition in pregnant women, there may be inadequate access to good nutrition for some, and others may have transportation means or otherwise to have healthier options. We would have to account for that potential of a non-equitable independent variable that would then have an effect on the total outcome of the study. There are two types of variables that can lower internal validity. Extraneous variables, which are any factor that are in the experiment but aren't being studied, and then confounding variables, which are related to the independent variable and affect the dependent variable. In research that draws on a quantitative research design, especially experimental research designs, also called intervention studies, we try and control these extraneous variables so that they do not become confounding variables. When an extraneous variable changes systematically along with the variables that you are studying, this is called a confounding variable. A variable is considered to be confounding because it provides an alternative explanation for your results. That is, an alternative explanation for the relationship or differences between the variables and/or groups that you are measuring. This threatens the internal validity of your results. Okay, again, remember how I said all research is flawed? Here is that potential again. These are sometimes hard to control for, and if we have a researcher that is not doing a great job at controlling for all of this, things can get mucked up without even being super aware of it. Well, there are some ways to control for extraneous variables, so let's look at some of these. Homogeneity of the sample is a means of controlling extraneous variables. Homogeneity means that the participants are all similar to some degree. For example, if we are measuring Lipitor to decrease MIs, it may be prudent to use an older population in which the risk of heart disease is similar. If we mix in some younger men and do not have homogeneity, and one of those younger men has an MI, then that would muck up our study, right? However, limiting a population also limits applicability as a population is very focused or limited. Randomization is a means of controlling extraneous variables. This means that every subject in the study has an equal chance of being assigned to either the control group, who has no intervention or normal treatment, or the experimental group in which they are receiving the independent variable as intervention. Randomization assumes that any important intervening, extraneous, or mediating variable will be equally distributed between the groups, minimizing variance and decreasing selection bias. Internal validity is the extent to which a study establishes a trustworthy cause and effect relationship between a treatment and an outcome. Internal validity also reflects that a given study makes it possible to eliminate alternative explanations for a finding. History can be a threat to internal validity. For example, if we are measuring Lipitor in high-risk individuals, but then the city they are in implements a low-fat diet for the population, that would change the physiology of the participants and thus change the results, perhaps without the researcher even knowing. Or, if the rate of poverty increases, perhaps those individuals in this study are eating cheap fast food. This would make the Lipitor appear as if it didn't work. Here's a research example. A research team wants to study whether having indoor plants on office desks boosts the productivity of IT employees from a company. The researchers give each of the participating IT employees a plant to place on their desktop for the month-long study. All participants complete a timed productivity task before or a pre-test and after the study, and post-test. A history threat would be, a week before the end of the study, all employees are told that there will be layoffs. The participants are stressed on the date of the post-test, and performance may suffer. A testing threat for that same research example may be participants showed higher productivity at the end of the study because that same test was administered. Due to the familiarity or awareness of the study's purpose, many participants achieved high results. Again, same research example, and the instrumentation threat could be, in the pre-test, productivity was measured for 15 minutes, while the post-test was over 30 minutes long. And finally, with mortality or maturation. Most participants are new to the job at the time of the pre-test. A month later, their productivity has improved just as a result of time spent working in the position. Do you see how some of these work and might affect the outcome? Now, external validity is the validity of applying the conclusions of a scientific study outside the context of that study. In other words, It is the extent to which the results of a study can be generalized to and across other situations, people, stimuli, and times. In contrast, remember, internal validity is the validity of conclusions drawn within the context of a particular study. And again, external validity deals with the ability to generalize the findings outside the study to other populations and environments. That's it for part 1 of methodology in quantitative research. Be sure to listen to part 2 as well.